Good morning. It's Saturday morning and it's 10:13 a.m. and nobody has showed up to learn about JavaFX. So I'm going to do a short uh, online tutorial and maybe even no, I'm not going to go through the video, but I'm going to show you which one's important, and then I'm going to show you some of the real code and the structure. Early on in Java, and I'm talking about pre-turn of the century Java. Java, of course, was created in '95, and between '95 and 2000, I think, or there was only AWT, Abstract Window Technology, or something, and then into like 2001 or two, they introduced Swing, which we used last week. In 2007, uh, Oracle, or I think it was Oracle by that time, may still have been Sun, they introduced JavaFX. And at least in my opinion, JavaFX is easier to use. It gives you a lot of capabilities that Swing does not. For one thing, it gives you the capability of styling some of your components, your buttons and images and labels, etc., with a style sheet containing CSS rules, just like you would with a web application. That's kind of nice to, which means you can include a CSS package in your, uh, which contains a style sheet in your output and in your project, and it will pick those styles up, and you can reference rules that make your buttons have rounded corners and look like buttons and all kinds of stuff that CSS can do. FX can refer to those in the FXML file. So let's get started. This is the okay. Let me continue on with my history. Um, in Java 11, Oracle dropped support for JavaFX, which was a real shame because it's, if they were going to drop support of anything, they should have dropped support for AWT and Swing. Since then, I believe the Apache Foundation, that does Tomcat and I think Maven and other tools, has been picked up by the group within the Apache Foundation, so JavaFX lives on. The problem is it's no longer included in the Java JDK as such. So it's up to us to bring JavaFX into our project because it's not going to be there automatically like it used to be in pre-11. The other issue with JavaFX is, I found it to be somewhat temperamental, even when it was included in JDK. And the reason I say that is getting it started, getting it to open up your FXML file and render a screen. Your environment has to be pretty much exactly right, or else you get an exception in the startup. And that's kind of a pain, but once you get around that issue and you can get a screen to come up, however else simple, you can move on. So since JavaFX is no longer part of the Java distribution, we're going to be using Gradle to bring it into our project and to build it, etc. So this is the key video here. Oh, wait a minute. Okay. I have been recording, but I haven't been actually sharing my screen. So this is the video that I was talking about. This is on the lesson 14 screen, and it's called An Easy Way to Use JavaFX 11 with JDK 11, Gradle, and IntelliJ. So the key thing is that you have to create a lesson 14 project within IntelliJ using this video. Follow it step by step. And he will show you how to create a Gradle project rather than a Java project, but it will include Java. But you don't create a Java project, you create a Gradle project. You don't create a JavaFX project, you create a Gradle project. And after you have a Gradle project open within IntelliJ, then you can use the new and JFX application, and it will create you a starting place for your project. Also, because of the way in which the startup occurs, the biggest problem with Java 11 is IntelliJ. One of the options is to include a bunch of extra stuff in your VM parameters. And that's exactly what we're trying to get around using Gradle. So it's imperative that you use the Gradle task run, which is part of the application plugin. Again, this video tutorial explains all of that step by step, but I don't particularly want to just play it here in at my recording. But I will show you the project. This is the way that you have to set up you have to have the project set up using Gradle and so forth in order for it to work. Under the source folder, you have a main, and you have a Java, which is your source root. You have a class edu_dccd, and within that within that package, you have a controller, a main, and a util. Now, this util is exactly the same one that we used in the last lesson. You will call it exactly the same way and get back the result. It will apply the rules and give you the result of that round. This controller and this main are generated by that create JavaFX application, which if you, I'll show you what I'm talking about. If I say new, right here, JavaFX application, but you don't use this until you've already got a Gradle project that will build and not, will have everything it needs to run. So, but that's how you get the initial controller and main. It also provides you an fxml file which is the same as the form in the previous chapter. Those are the three components of FX: the controller, the main, and the RPS fxml. One of the also differences with JDK 11 is you'll see that the fxml file is separated from the two Java classes, and it's in the resources folder, which is under the main. It's not under Java, but it is under source in main. And there's the RFS, but we'll look at the actual contents of this in a moment. Also, under that resources, I put an images folder, and here is the three images that use for this project. You put them in the images folder, which is outside of the package edu DCC. But it's directly under resources. So now let's look at some of those components. The first thing is let's look at the Gradle build. This is the one that when you create a basic Gradle project, you don't have all these things, so you'll have to add some of these things. The main thing is the first thing you want to add, according to the video, is this plugin for the Open JavaFX, Java JavaFX plugin, version 0.0.7. That plugin allows you to then put in these lines here, the JavaFX section, and we have modules, and this is the JavaFX controls and the JavaFX XML. Those two packages within the Open JavaFX is what makes this run JavaFX. And a module, the version is 11.2 of those controls. The other thing that's important here is the application plugin. The application plugin allows you to add this line at the bottom: main class name equals, and you put the class name of your main program, which is, of course, edu.dccd.jps main, RPS main. So that's our Gradle build file. The important parts then, as I said, are the JavaFX plugin here, the JavaFX section here, the application plugin, and of course this line here has to identify specifically what your main program is. And I also changed the source compatibility to 11 or 12 here. It doesn't matter, but that allows you to run the latest compiler, etc. So that's our Gradle build file. You want to make yours look like that. So next, let's look at not util. It doesn't change. Main. This is your starting point. This program is where Gradle will look for your main method here, the public static void main, and will launch the application. Notice that RPS main extends application. This application refers to the JavaFX.application.application class up here. That is the superclass of your main program. So what you do within the public static void main is you call a launch method, which is in fact inherited from the application class, and you pass it to command line args. No big deal. They're not really used, but this launch gets you from this main program into the JavaFX, and so it has control. So then it's going to come back to your program to this start method, and it's going to pass you something called a primary stage. And within this method, we create a parent object called root or whatever you want, and it uses the fxml loader class and we use the load method. And within the load, we say get class dot get resource, and the resource that we're going to load is /edu.dccd/rps/fxml, and that URL refers to this program. It looks for the resource, and within resources, it's going to look for RPS XML within the edu.dccd package. So then we create a scene using that. Well, before I go on, this is where your FXML controller, a FXML file is loaded, parsed, and also the controller comes into play, which I'm going to come back to that in a moment. So after we've created this root and we've got our FXML file loaded, etc., we're going to create a scene with that root. We're going to set a title for this stage. We're going to set the scene into this stage, and then we're going to issue a show. At that point in time, that will open your screen and we'll render it on the page. And after the show, JavaFX is waiting for something to happen, an event, a button is be pressed or something. So this is what our RPS main looks like. All right, the next thing I want to show you is the FXML file. This is the FXML file. This is the text of it. It is an XML file. It contains something called, this is generated by that Create JavaFX application, by the way. But you're going to add some to it. The lesson also refers to the scene builder, which is a program that you have to download and install on your system. And this allows you to graphically create the screen. And here's your palette of things over here that you can use. These are different kinds of containers. In the last last lesson, the containers were things like frames and panels and so forth. Then down here we have within, this is our actual screen itself that we pulled together, because in addition to the containers, you have controls, you have menus, miscellaneous styles, charts, etc. And we've drugged an anchor pane out here, or I think that's the default. You get an empty anchor pane. Then you have these labels. This one is going to say your, and that's right there. Down here is referring to this label, which says is the computer. These are just headings on the screen, if you remember. And here's another label, and that's the area in the middle where the result is going to be displayed. We have an image view here. This one is the computer image. Here's another image view on this side, which is the user image. Then we have our buttons. We have the rock button and the paper button, the scissors button, and a new line button. The a new game button, as far as I'm concerned, is totally optional in this exercise. You can play with the rock, paper, scissors all you want, and when you're done, you can click the X in the corner or whatever to close the program. But this graphical representation of this is what that XML was. So let's look at this button. If we highlight the button, it opens the properties for the button over here on this side. The text that appears on the button is rock. The font is System 1 and regular 13. You can change that and make it bigger if you want. What else do we have? It has no inserts. It is visible and traversable, and shape and scale shape are all good. This is a accessibility roll button, so that makes it a button. Under layout, we've made the preferential width 80, and otherwise it uses computer size and for all of these different values. It has no padding. Layout, when you drag it on there and position it, it's, this is at 42, 190. 42 across and 190 up. Okay. Then we have the button, the code tab for the button. Here is the FX ID. The FX ID is the ID that it looks for in the program. So it looks in the program for a button called rock. On action here, this is the name of the method in your program, which gets called when you click on the rock button. We'll look at that in a moment. Those are all kind of mouse issues. That's basically everything for, I think, for the button. So now let's, and again, this screen creates diffx XML file. In this file, I want to point out some things that are very important to you, and some of them are off the page, so I got to do a little reformatting here to see them. But one of the key things in here is the FX controller. This refers to the name in the package of where the controller class is. Ours is edu.dccd.rps controller. And IntelliJ shows that as being is green, so that means it's been found by IntelliJ. It links up this this reference to IntelliJ. So here I'm here is the I've just added the DCCD to the project library so it doesn't show it as a misspelling. Down here, those labels and buttons that we put on the screen. Here's the location. There's the text for those labels. Here's the image view. It has an FX ID, computer choice image. That'll be referenced in the controller program. So that's where you put your images. Here's the size and the layout. Down here on your buttons, here are the 4 buttons, and they have an FX ID, so that relates to the buttons in the program. Here are the layouts. Here are the on action. Notice the pound sign at the beginning of it. Rock listener is the path, the method within the program that you're going to handle the clicking of the rock button. These are green. Otherwise, if IntelliJ was not able to find those within your RPS controller, they would be red. Likewise, if you didn't, these FX IDs are not actually referenced in the program. That's why they're highlighted. They could be removed. But the buttons, the on action is important because this refers to the method that gets called when the button is clicked. You need an FX controller that matches, and your message area where you're going to put the the output results has to have an FXM ID so that the program has a place to put those messages. See, it's not, when I get off of it, it is not highlighted like the rock, paper, scissors is down here. So that messages field is used, this computer choice image is used, and this user choice image is used. So those are fields within the program, and they're hooked in the controller program, and they're hooked to the program via this FX ID. So that's our FXML file. All right, so now let's look at the controller. So when the main starts up, it launches, goes into JavaFX. JavaFX comes back to the start method. The start method does that FXML loader. It comes down and opens this file, parses this information, and finds out, I got a controller. So then it loads this controller class. And this controller class is does all the screen handling, etc. But after it loads the FXML file, it looks to see if there is an initialize method within the controller. And there is, so what this does is it creates a new image of that rock ping. Notice how it's referenced /images/rock image. That's the folder they're in within the resources folder. And it creates a new image from that URL and stores it in this variable rock image, which is a type image. Same for paper and scissors. Here's the messages. Again, the FX ID for message in the FXML file is messages. And we set the text of that message to new line, rock, paper, scissors. Okay. Then here are, also notice that this label and these two image views, they have this special symbol out here which says those were matched up, and also the annotation at FXML. This matches up the FX ID for these fields with these fields in the class. That's very important that you see those. And the other thing that you have here is primarily your listener classes. The listener classes, this gets the computer choice, which is a method which does your random and your next int for a bound of 3, because we have 3 image. And let me tell you, this guy should be not there, in fact, but it should be up here. Let's put it up here. And we make that up, and then we're going to copy that, and we're going to drop that down here in our initialize. So that's going to set up the random one time in the initialize method. So now up here, we can take that off, because all it's going to do is reference, if it is declared up here, this is where it's actually going to initialize it to a new random. Therefore, the only thing we have down here now is just this ran.nextInt bound 3. That comes up with the computer's choice, and this returns a 0, a 1, or a 2 for rock, or paper, or scissors. And each of those call that method. Then it sets it calls RMMS util to determine the winner. It passes the user value, which is 2. And okay, that's the scissors. Let me show you something else that I would recommend we do. Let's go up here and create a VSF. Nope. Private static final rock equals 2. We got to have a type for rock, and so it's an int. Okay, and rock is not 2, in fact it's a 0. So now let's duplicate that. Let's duplicate that line, change this rock to paper, and this rock to scissors, and this is a 1, and this is a 2. So now we can come down here, and in our rock listener, we don't have to call it with a 0. We can call it with rock, and it's the same difference. And we can, instead of calling this with the number 1, we can call it with our paper. And down here we can make this 3. Scissors. Okay, so we got rid of those. Now the other thing that you also can do, by the way, is these are those image fields. Rather than use 3 separate fields, let's set up a private image array called images equals, okay, and now down here when we load these images, let's set images equals to a new image array, and then what we're going to do is, instead of putting this image into rock image, we can put it into images sub rock, and instead of paper image, we can call it images sub paper, and instead of scissors image, we can call it images sub scissors. Okay, so now we got these into an array. Well, that's nice, because now we can, when we set the user choice to rock image instead of a rock image, we can put in the images sub rock. Okay, and down here, instead of paper image, we can call it images sub paper, and down here we can make this images sub scissors. All right, so now we have made that a little more generic. Now down here, these ifs, I don't like those. 0 is rock, and again, this would be images sub rock, and this would be images sub paper. And this would be images sub scissors. All right. And we can change this to, say, paper. And now, you know, we've generalized this. So let's go a step further and do a refactor on this. Let's say what did I call it? You can just call it process, which is the name of a method which we haven't created. And we're going to pass it a parameter of rock. Okay. And now we're going to actually take all of this and we're going to say refactor extract a method. Okay. And one, two, three. Okay, so now we get rid of our, okay, that's down there. So now we should be able to highlight all this and say refactor extract a method. We're going to call it process, and we're going to pass in a int, and we'll just call it let's just call it user. All right. All right, let's just do it that way. Say refactor. Okay. Okay, but we're going to change this. I had to extract it without a parameter, but we can extract, we can add the rock in there as the parameter. Now, if you come down here to process, where's process? Process is right here. And see, now it gets the computer choice. It sets in here. Oh, we have to put a int and user right there. And now we need to change this to user, and this to user, and these to images sub choice. And now see, we can actually get rid of all these darn ifs. And so you see how, whoops, there's a little, one line too much. I want to get rid of these else's. So now, see how concise this is? This says to get a computer choice, which is going to return choice, which is the computer's roll of the dice. We're going to call the determine winner with user and choice now, user being the parameter in and choice being what we got back from there. And then we're going to set the user choice from that array of with user as a parameter, and we're going to set this computer image to images sub choice. And so now there's the rock listener. We say rock. We say paper here, and we can get rid of all of that extra stuff. And under scissors, we're going to, we're going to say process scissors. And we can get rid of all this stuff. Now see how we have simplified this program, made it more readable, and utilized constants, etc. Now let's go back and rearrange a couple of things. Let's cut that there, and put this down here. And so now the all of the listeners together. This one just goes back and resets things. So we're not going to do anything to this. Here's our process method, which handles all three of the user choices, whatever the user chose. And in fact, we now can simplify things by taking this and putting it up here. And instead of a 3 here, we're going to make this images dot linked, which is of course 3. Not return a value from a method with void return type. Okay, we're going to set this to okay. All right, so now we can get rid of this line, and we can over here and move this line above it. So get computer choice just does that, and that means that this method is no longer needed. Okay, so see, I've simplified this using the named constants and so forth, and we have a couple things. Access can be private, so let's clean up a few of these little things. Make it private. Private field. Rock image is never used. Yeah, so we don't need these any longer because we're using the array. And now we have a green check mark again. So you see how nice this cleaned up. And in fact, we can maybe get this on a single page so you can see it. And if I put these on the same line, it's not exactly the right style, but it makes it easier to read on the screen here. And so I don't guess we can really make it any shorter without getting rid of things. So here's the top of the controller. We have our random field. We have our named constants for rock, paper, scissors. Problem. That should be a 2. Then we have our private fields for the components that are FXML matched. Here's our images array. Our initialize routine is kind of like the constructor of this class, called by JavaFX. When you load the FXML, it creates the random, and it creates the images array and adds puts these images into that array and sets the initial messages. And here's our listeners. They're all concise. They just call process and the appropriate constant. Because it's the rock listener, we call process with the rock constant, and so forth. The new game listener, we're just resetting things. And actually, we could yeah, that's fine. And then this process method takes in what button basically the user pressed, and it gets the computer's choice, and it goes in through the RPS util, determines the winner, and then it's going to set the 2 images based upon what came in as a parameter here and what came back from that. Boom. And so now the key thing is that, as I said earlier in this set, we have to use Gradle to execute this. We can't run it by just clicking on in the main, clicking on this green icon, because if we try to do that, it's going to give us an error. See, but if you go over here to the Gradle tab, you'll notice that we have a task called application run. This was created by the application plugin in the Build Gradle, and we run our project this way. Hold our breath. There is our screen. There is our screen that we just created from this program. If we click on rock, it's a tie. Click on paper, it's a tie. If we hit on scissors, it's not a tie because the user selected scissors and the computer shows a paper, and so the user won. If we hit new game, it resets the messages. Now, I probably would do some cleanup of the screen and make this a little wider so that these things fit in the middle without this truncation, etc. But I'm not going to worry about that right now and won't count it against you. So that's our rock, paper, scissors game. So, and see, when we click the X in the corner, it did it finished the run. So make note of this structure of your project and where things are. I've shown you the methods, etc. And I think that's just about it for today. Email me with questions, but like I say, it's important that you use Gradle. Create a Gradle project. And after you have a Gradle project and it's gone through its build, initial build, etc., then you want to create a Java application, a new Java application, which will create the basic main controller and fxml file. Rename them and start putting your code into those. So that's all for today. It took just about an hour, and so I'm done. Thank you for taking this class. Thank you for watching my video. Be sure you watch the other video to figure out how to do it. And that's